Yeah, as was already mentioned before, I was going to present to you guys today a little bit about Conda-Store and what exactly that is. This is a project that at Quansight, I think we started about 2 years ago. And in the past, I would say 6 months or so, have really been actively developing it and trying to add features. So really excited to talk to everybody about that. So a little bit about myself. I'm a software developer at Quansight. Kind of my background was computational material science and computer science. I've always really cared a lot about numerical computing, and then I got hooked on a project called Nix packages, and then really cared about reproducibility in packaging. Other things that I am actively involved in. I contribute to a lot of open source projects, mainly around like the PyData space. But the two major ones, JupyterHub and Dask, are ones that I'm involved with. And then not so affiliated with the Quansight work that I do. I do a lot of NixOS, Nix packaging work. And then other kind of thing that I've done probably for the past 10 years is I've had some sort of home lab in my basement. And I think that's been a really great way to learn about databases and all sorts of things that you want to run. I get to crash and burn with everything at my house. And then when I start doing actual real work, then I've already made the mistakes at my house. So things end up a lot better that way. So just wanted to say really quickly, just a little bit about Quansight. So the way I think about it is that Quansight is trying to make open source sustainable. Its mission is to, through consulting and other means, we get funding to sustain NumPy, SciPy, SymPy, a bunch of other PyData projects out there. And we have dedicated developers towards that to make sure that all the maintenance is being done on these tools that really everybody benefits off of when they get continued. Okay, so before I even talk about necessarily what Conda-Store is, and I'll have some demos on this, I think I want to step back and say, like, why should we even have environments? So some people might think of Conda environments. Others might think of maybe like a Docker container as a development environment. Maybe we have, if we're doing some JavaScript development with NPM, we can have node environments. But the whole idea is having some sort of place where we have all the packages we need to do our development or running a piece of software. And I think the core reason I think of having a well-defined environment is that eventually you're going to have to onboard other developers to help you on this project, or maybe try to get contributors involved. You're going to pay this debt at some point, and having a well-defined environment with the packages that you depend on is really useful for any software project that you do. And then we kind of move on like past why should we have an environment and why should we have many environments. So when I started developing, I had this monolithic environment where I just installed everything into the same environment. And it turned out that that was pretty brittle, and for many reasons. One of them was that really packages update quite frequently, and you have incompatibilities between packages that might prevent an update taking place. And then finally, if you have this huge monolithic environment, it's going to be much harder to share that with other people, maybe in a Docker container, or let's say an environment.yaml file we have in here. If it's really long, install times are affected, like all sorts of things. So really trying to encourage this practice of having not just environments, but having multiple environments, and each one defining kind of the piece of software and how it runs in as minimal a form as possible. And then I think the final point is reproducibility. We want to strive to be able to run things many years into the future. And that's actually a harder problem. It's actually quite a hard problem. And I'm hoping that Conda-Store can kind of help with that. And I'll talk about that a bit more. So then, once we've kind of established, okay, environments are useful, why Conda? Python has a great package manager, pip. Why not just use that? Well, the first thing that comes to mind for me is Windows, Linux, and macOS support. When we talk about all the package managers out there, there aren't many package managers that support such a support all three operating systems. We can just think about Ubuntu and RHEL and Debian, all of those with having apt or yum, those tools. Those tools are Linux only. Then you have this other concept of isolated environments. So a lot of these tools also don't really come with a concept of an environment. More, they just have like a monolithic environment. I think of, apt is a good example here, where if you um, install curl or something, that's going to be installed for every user on the system when you do that. But maybe I just want to have that package for just my development and not affect other people. Other things that can be really useful is having really a programming language agnostic packaging system. So I would say that pip is really Python specific, but it doesn't really handle C and C++ and Fortran and R, and just the list goes on, and really need like a programming language agnostic packaging system. The other one is, especially within the PyData ecosystem, you just need to have something that has a lot of adoption in the scientific community, and Conda is one of those. And this last point is the one that I think doesn't immediately strike people as why we should use Conda, but if you're doing any sort of scientific work where you need compiled libraries, NumPy is a good example, Numba, like list goes on. Eventually, you have to compile things, and in the case of NumPy, you're going to have some sort of BLOS implementation compiled. Maybe if you're using SciPy, you'll have some fast Fourier transform library compiled. And if you're using pip and PyPy, you'll say, oh, great, they have wheels. Well, the wheels actually vendor in the libraries themselves, and they pin you to a specific version of, say, OpenBLOS. But you're not able, maybe another package that you get with a wheel has a different version of BLOS, and you end up like using different versions of compiled libraries, even though you're using kind of the same Python environment. And this is something that Conda really solves for you. And all these kind of boxes that I'm talking about here, Conda ends up being one of the only choices in this space. Now, there are a lot of package managers, and I'm a big Nix advocate, but I think that Conda really fits these use cases extremely well. Okay, so now that I've kind of given some background on Conda environments and why that's all important, I think it's great. You can create a Conda environment, you can do your development, but we started realizing that there's a lot of shortcomings to having an environment. You define it in your environment.yaml right here in the bottom right, but there's a lot of things that this just doesn't address. So one of them I'll talk about is, I think of this triangle kind of addressing what we're trying to do here. So we have IT's responsibilities with environments. We have users and what their expectations are of environments. And then we have reproducibility up here as well. So a common thing that we initially saw when dealing with environments in Kubernetes, and also just contracting and working with our clients, is that there's a lot of friction between IT and the users. So as a user, when you're just developing, you need NumPy and you need it now for your work. Well, there might be reasons, you'll go and contact IT and you'll say, hey, I want to have NumPy installed. But IT, on the other hand, has its responsibilities. They need to ensure that the package that you're installing is compliant with their policies. That might have to do with licensing issues. And then as soon as that's all been approved, maybe they have to build a Docker image with the package that you need, upload that, change some configuration here. And after all this is said and done, this could be 2 or 3 weeks. And that's a real big pain to end users. At the same time, like IT, they're just doing their job. So really, I mean, both sides are completely right, but they both are frustrated with each other just because of the process. And we could make this a lot easier on users. Other problems is that, let's say a user develops an environment and they're not really meticulous on what packages they've added. They might not be able to reproduce their environment, say, a year down the road. Okay? Another use case too is that a user develops a JupyterLab notebook in their given environment, and they need to run that, and they need to run it for the next 5 years. And so they go off and they contact IT and they say, hey, I've got this notebook, I want it to run. And now kind of the responsibility is on IT of maintaining that environment that that notebook ran in and making sure that it can run continually for that amount of time. And that's actually a really complicated problem. And I'm hoping that Conda-Store kind of shows, how we can start to address these problems. So after I've given that whole introduction, um, really what is Conda-Store? So Conda-Store is a tool that we designed to manage, build, and serve environments. And it aims to do each one of these really well and be hyper-focused on just environments. So how does it manage environments? It provides a web UI that I'm about to just show you right after this. It has a full REST API for managing environments, which can be really useful if you have some sort of, some pipeline that needs to automate something. It can be entirely automated, all that stuff. It also watches your file system for any environment changes in environment.yaml files. So it can also kind of be run locally in a sense there. And then finally, we've got something that we're really actively working on, which is a JupyterLab UI for managing environments. And that's very much a work in progress, but I'll be able to show just a little bit of that. Then finally, since this was really designed with enterprise in mind, it is designed to build multiple Conda environments concurrently. So the way that it's been designed is that it should theoretically be able to run N workers and build N environments at the same time. And then finally, I think the critical piece to Conda-Store is that once you define your environment, it tries to serve it in as many ways as possible, because there might be a need for an environment to be in a Docker container and run on Kubernetes, but that same environment, maybe a developer wants to use it on their laptop, so they want to download the environment.yaml file. Maybe you have an HPC cluster that doesn't have support yet for, won't run Docker, and you need to use some sort of other container format, or maybe you want to use CondaPack. Really, everybody needs the same environment, but they need it to run in different ways. So we're trying to enable that. And then finally, the last piece is that there's full role-based access around all of these things. So it's very enterprise friendly. And I'm going to just demonstrate that really quick and show what Conda-Store is. So here I just have pulled up the Conda-Store web UI. And here we can see that we have a namespace, and then we have the environment name itself. And right here, I'm just showing that I have a Quansight data science environment defined. And you also notice that there's a default data science environment, a default namespace data science environment. So you can actually have the same environment name exist in multiple namespaces. And I like to think of this kind of as the Docker hub for Conda environments. So let's just click on this Quansight data science. One thing we can see really quick is the environment.yaml file that was used to build this environment. And then we can actually see the actual builds that took place. So currently there's only been one build. And if we click on that, we see it completed. So we click on it, we can see when it ran. Again, the environment.yaml. Conda-Store deeply understands the packages that are in an environment. So it gives us the list here. There's a lot of other stuff we can do there. And then it gives us finally the build assets, the build artifacts of this thing. So we have the environment.yaml file that's locked down. We have a lock file and a tarball of that given environment, and then a Docker way to pull it with Docker. And then finally the logs. So you can imagine that the build fails. Well, here you'd be able to access the build logs for the environment. So, one thing that I'd like to really enable here is that, a user needs to make a modification to an environment. So they'll edit it, and then they'll add, let's just, another data. Let's just add pandas, for instance. So once you submit pandas, we can now see that another build was triggered right here. The other thing I want to show is that the way that environments are built is that you never actually do an update. You do a complete new install every single time. And this way we have the ability to do rollbacks between environments. So if we find out that the new environment that we built is broken in some manner, we can actually update back to the a designed environment for users. We also have abilities that we can delete certain builds, and we can also re-trigger builds, because in Conda, this is not a well-specified file. So it might be that Numba gets updated, and when we trigger a rebuild, it will use a newer version of Numba. And again, it will keep track of all those versions here. As you can see, so the Quansight data science environment is being rebuilt, and right now it's only built the log file, but we'll see other stuff pop up really soon here. So we have a YAML file, and then we'll have the archive. So if we just click on one of these, we can see the log file, and this looks really messy, but this is a completely reproducible way of getting this environment. It even gives the SHA hash of things. Another artifact that we have is the pinned YAML file. And then another one is CondaPack, which is a tarball of the given environment. So if I'm just extracting the environment here, and we can actually see all the packages in here. And this is just one that you can run on your own machine quite easily, and the docs talk about that. And then finally, you have the Docker image. So I'll just give an example here. I have this Quansight data science environment that, let's see if the Docker image has been built. It hasn't quite been built yet. I'll just wait a second for that one. Okay. The other thing I wanted to show was that you can create environments. So here we can create an environment. Dependencies, and then here we'll just like add Flask, for instance. So as soon as we submitted that, we see that a new one was added here. And because we can actually do concurrent builds at the same time, it's actually building a Docker environment, a Docker image, and it's also building this image itself. Another thing I want to demo really quick is this concept that we have role-based access. So right now I'm logged in as a user, but let's see, I want to show how you can't actually see all the environments if you're not logged in. And this is all very configurable. So we have a given user, and if we log out, we'll see that default is the only namespace that we can see. But as soon as we log in, here I'm using Jupyter Hub OAuth, and you can see that these environments are available. So and there's a lot more controls to all this that can all be configured behind the scenes. Okay, so I know that was a really long demo of all this stuff here. Oh, and then the last thing I wanted to show this Docker bit here. So we see that there's a Quansight data science, and I want to work with this Docker image. So I can actually just open a terminal, and we can do like a Docker run -it localhost 5000, just because that's the port it's running at, and then we'll do Quansight data science. And you can actually see that right now it's interacting with the Conda-Store web server, and it's downloading the Docker image. And this is all backed using an S3 object store behind the scenes. So we also get, I'm showing just how many ways that you can get your environment available to your users. And then once we have this Docker environment built, should show up in a second. We import pandas, and we see that this all works. So that environment was successfully built. Okay. So all this stuff that I demoed to you, also I forgot to talk about this one. So this is the JupyterLab UI that I was talking about a little while ago. And the idea is that we want these environments for the users not to have to use the web UI. We kind of want them to live in JupyterLab and be able to modify environments all with the correct access controls there. And I'll just show that really quick here. So here I have a Jupyter Hub server running. We can also see that several of these environments are available to us. We have our web dev and our data science environment. But let's go to this Conda-Store package manager. So again, still very much, we haven't really set up authentication properly here, but you can see that you can only see the default in these environments. and then we're still filling things in and all that stuff. But we at least have the start of this, and we're going to develop it much further. Okay. So all of this stuff that I had shown you here is just, you can try it out yourself. All you have to do is clone the Conda-Store repo, go into the Docker example, and then just use Docker Compose up to run it. Also, I think this is a good point to kind of show all of the pieces of Conda-Store. So we can see that there is a, okay, so first there's the Conda-Store thing available on port 5000. That's just the web UI, also the REST API and the Docker registry all in one. And that's this piece right here. There's also in Conda-Store workers, and then all of the data is stored in the database, and then anything that is a build artifact is stored in the S3 bucket. And then finally, we have a shared file system. It just writes the environments to a file system. So this is another way that you can expose it to users. Maybe you're on an HPC center that has a high performance distributed file system. It will write those environments to a given path, and that can be easily then accessed by the users. So kind of showing, how exactly does Conda-Store work? So I think this is a good way to show this. So you have a given environment we have defined here, and this environment points to a particular build of a given environment.yaml file at a point in time. And we can see that, maybe one of the builds failed, but another one of these builds succeeded. And we have an easy way of sort of keeping track of every build that we have of an environment.yaml, and also being able to easily point the user to whichever one is currently active. And I'll also say that every build has a unique key associated with it. So you can actually reference builds way in the past via that key, which really gives you the reproducibility if you need to run the exact same environment, maybe 10 years down the road. You certainly acknowledge that there are security vulnerabilities in these packages, but maybe you're running a workflow that's kind of isolated and it just needs to continually run for a long time. So here I just wanted to kind of point out, I kind of mentioned this a little bit before, but I wanted to talk about this more and talk about how Conda-Store actually addresses this. So I mentioned how end users really want new packages as soon as possible. And I think it's really understandable how they're like, what's so difficult about this? It's a Flask web server. Everybody uses it. There's no issues, and kind of being frustrated with the amount of time that it takes for IT to get back on that. And then, really understanding that on the IT side, they have a lot of responsibilities as well. They need to vet a package, make sure that maybe, the SHA matches, it meets all their criteria on licensing and a bunch of other, things. Maybe it has to come from their specific channel that's been vulnerability scanned. Then, like I said, they might have to build a Docker image, and really that takes a long time. And how can Conda-Store kind of get between these two users and make this process easier? So I mentioned already here that Conda-Store has rich RBAC controls, and this allows you to say if users are allowed to just use an environment versus modify it or delete it. All of this stuff is represented at the low level, which allows you to have tight controls over, users can only write to their user namespace, but maybe your company has a company-wide environment that is protected and only IT can modify. The other thing is I'm building this to be quite a bit more robust, but having constraints on what channels can be used, what packages must exist in an environment, a whole bunch of other controls on these things. Maybe when an environment is built, it's when it's written to the file system, it's owned by this particular user and group, so that users can't edit it, or only a certain group can see those files. That's the sort of controls we want to have there. And then here I also mentioned like a dedicated namespace to users. And yeah, so really a lot of things in this area that we can use to make this stuff easier. Another one that I slightly hit on was productionizing environments. So, we have a JupyterLab image that we're running on Jupyter Hub, and a developer creates a notebook, and they want that notebook to be able to run. And they might be using a service like Papermill, and Papermill allows you to kind of productionize and make workflows out of notebooks. But I think the big missing piece there is how do you guarantee that that environment is always going to be available? So the way that Conda-Store addresses this is that every build is uniquely addressable. So, this build, since it's stored in S3 as a blob, we sort of have a guarantee that that environment is going to always exist and be usable. Other things is that all builds output walk files, pinned YAML, conda pack. So you have a bunch of different ways to access those given environments. They're also always archived in S3. So that makes it easily, if you have some sort of backup strategy you want to do, that's readily very easy. And it also ties into all the cloud providers quite nicely. I'll say locally and for testing, I've been using MinIO, and it's worked even well for on-prem deployments. The other thing is that, an environment is never updated. There's always a new environment is created. And this is really, I'd say, an issue specifically, I think, about Conda, and you'll probably run into this one out of every 50 tries. But once you have an established Conda environment, that affects the future solve. And it might cause it to get in a state that it's not able to kind of back out of and update all the packages in the right way. So it's really a good idea to always start fresh whenever you're updating or creating a new Conda environment. And then the last thing that I really wanted to talk about was on-the-fly environments. This is something I really want to catch on, and I think maybe, I don't know, I just think it's a really exciting use case of managing environments. So I've often seen where you need to run an application or a piece of code with some configuration. Pretty simple there, but it's often quite a hassle to create the Docker container and then create the Docker container, upload it, and then begin running. Like, there's just two steps that I think are unnecessary. Users shouldn't be concerned about building these Docker containers because we end up writing these Docker files and they pretty much always look the same anyways. So how can Conda-Store kind of help here? So one of the things is I want to show that there's, I have this idea of like on-the-fly Docker images that can be built for Conda environments. This is really motivated by a Nix project that I saw, and yeah, I just wanted to demonstrate that really quick. So here we have our given environments, but we'll notice that, okay, so we have these environments, but I just want to run a Docker environment. Okay, yeah. So here, let's say I want to run JupyterLab, and I don't necessarily, I want JupyterLab and I want NumPy to be available because I want to run a JupyterLab server, but I don't want to build the Docker image explicitly. So what you could do is localhost 5000 Conda-Store dynamic, and this is part of the main reason why in Conda-Store I implemented the Docker registry. It's so that we can do interesting tricks with the Docker protocol. So here, let's say I want JupyterLab to be installed, and I want NumPy to be available, and then I want Python less than 3.8. I had to kind of lie about the syntax here just to get it to work. But as soon as you run this, you'll see that it says it doesn't exist, and it's kind of just waiting. And the way I've implemented this is that it just, it says the image exists, but it doesn't respond with the actual contents until it's ready. So if we look back here, we'll see that it's actually created automatically an environment for this. And we can kind of adjust whether users actually see this or not. It's already defined this channel, and you can see it's already building. And in fact, it's going as far as it's building. It's going to build that Docker container, and then this Docker run is just going to work. So this is a way of like having these, what I would say is, Docker images that don't really have any secret sauce in them, and they're just very tedious to write, and who wants to actually write them in the first place? So let me show where I think this is really useful, which is in a Kubernetes context. Sorry, headset died really right there. So here I have a Kubernetes cluster running. Conda-Store is just running in Kubernetes here. So if you want to try this one out, I have examples Docker. I also have an examples Kubernetes, and there's a customized bit all to just launch this really easily. You can try it out with Minikube. So here we have our server, our worker that's responsible for the Conda image builds, MinIO for the S3 objects, but you could also tie it into just any compliant S3 object like storage. And then Postgres, again, I'm using SQL Alchemy, so really anything that's database-like, you should be able to hook into. So here I have this pod I'd like to run on Kubernetes. And then here, all I have defined is this Conda-Store dynamic bit. And notice how, I don't really have this image. I didn't build it. It's not on Docker Hub. And if I do a kubectl apply of this, so I created it. And then if we look here, we'll see container creating. And if we just wait on this, it's going to take quite a while. It's going to be this exact same process that I've shown here. You can actually see this image I was showing before. It's actually pulling this at the moment. So this Docker image got built on the fly without us having to specify it. So I don't know. This is me kind of hoping for a future like this in Kubernetes, and maybe trying to enable these sort of workflows. So I know I spent quite a bit of time on that, but I hope something can come of that. So then finally, just wanted to talk about the roadmap and then really open it up for questions. So one of the things that I really want to do is make Conda-Store a public service. It is a fully open source piece of code that anybody can use and run on-prem however you want or in the cloud. But I want to enable like Conda Forge and these other folks to have a remote Conda environment solve. And you might have had to do a Conda solve before. It's a really large environment, and then it just consumes way too much memory and it just crashes every single time. Well, it'd be really nice if we have a specialized service for doing these sorts of solves, and having a Docker Hub-like environment for, let's say Pangeo publishes an official environment that people should use. Well, I'd really like to have a service that people can just kind of readily use that. Maybe assign DOIs to those environments, and then now we have like enabling further reproducible science. So really trying to help having reproducible environments. Another thing, I've talked about the JupyterLab UI. I showed you something that's really not totally working at the moment, but I just want to kind of let us dream on where this could go. Integration with Jupyter Enterprise Gateway. This is being able to run kind of really custom on-the-fly JupyterLab kernels and kind of separating the kernels from the JupyterLab web server. I think this is a really, really key piece that could really help Jupyter Enterprise Gateway and help the whole Jupyter Hub setup. I really think this is a critical piece getting this working. Serving additional environment types. I've talked about Docker and Conda Pack, but it'd be really nice if we could serve Singularity environments for HPC users. And if we talk about how Dask is being used and coiled right now, when you spin up and you run a Dask web server and worker, when you run a Dask scheduler and worker, these are spun up VMs. And I'd really like Conda-Store to kind of help out with this as well. And maybe we can build ISOs that will be able to easily run on AWS or GCP. There's kind of a Kubernetes tax running it on a given node, and maybe we're just better running on pure bare metal there. And then finally, Quansight, we've also been working on something quite a while called QHub, which is I would say like an auto-scaling data science environment for people that don't know anything about Kubernetes or the cloud. And we're really hoping to, very soon in the next, I'd say month or so, we're going to integrate this with QHub and get that to make it so that users can easily modify their environments. With that, I just have some links to the docs and then also the GitHub repo. And yeah, would like to open the floor for questions and really thank everybody for their time.
Awesome. Thanks, Chris. So I'm going to open up the chat for anyone who wants to ask questions. So you'll be able to unmute and ask a question.
I can check and see if is there chat.
Yeah, people can send in chat.
No, the chat's still locked down from everybody, but I think we could just send direct messages to you and Chris.
Yeah, I might be able to see it. I got a direct message that somebody said, "Yay, Home Labs." Yeah, I've had that, had one for quite a while, and it's a nice way to geek out. And I ran Ethernet through the whole house, and that was a fun little process to do that.
No, we're going to talk about that when we hit the free time. I actually am really excited about stuff like that.
Oh, awesome.
But on Conda-Store actually itself, I really like this project. I know that I've been having some problems with Conda sometimes giving me packages that I didn't want, and I really wanted a good way of saving and storing. I tried YAMLs, that didn't work out so well. And even Conda Pack, especially for like Colab. Do you see there's a good way of doing this where we can like basically take install something on Colab, install your stuff, save an instance of it, and just make it reusable in that way?
I mean, the first thing that comes to mind with Colab is this sort of Conda Pack thing. I know it's not the greatest approach, but you could, download the Conda Pack tarball and extract it properly, and you would have that environment available to you. And I guess Conda-Store outside would be managing the actual environment.
Yeah, we tried Conda Pack before. It ended up being massive, so it was kind of nice to like just say this is exactly what you need.
Yeah.
Because the YAML files, once somebody changes the label, the whole YAML file is gone.
Yeah. So here I wanted to show, so I gave an example of this Quansight data science environment where we did 2 builds. It actually saves a YAML file for each one of these builds, so it's never really lost when you update it. Here's one that's not, the build 2 is not current, but we can still access the environment.yaml and the Conda lock. And actually, if you're going for full reproducibility, and assuming you don't have any PyPy packages, so Conda lock doesn't support pip, but this is a way to like truly guarantee that you have the exact same environment. And maybe this is the nice way, since Colab has a fast internet connection, you could use this format, and it's super lightweight because you just download like a 1 kilobyte file.
Oh, nice.
Again, I think this is part where I don't think that I can anticipate how people will want their environments to be served to them. So this is like, let's just serve it in as many ways as possible and give them that sort of guarantee that they're all the same.
Yeah. I love that. Good job, man. I'm
Thanks.
excited to see where this goes.
Yeah, we are too.
Have you thought about slightly generalizing this and kind of view it as, you can view Conda as the main environment and package manager, plus, okay, well, I need a few more things to also install that you can't really do with Conda.
I've thought about that. So you're kind of, talking like what here I have. If you're using the environment.yaml, you can just as well start naming pip packages in here. And I thought like, what if we like add npm in here or something, and then we'll have like JS math. Here I'm open to that idea, but I really wanted to stick to what is part of, the Conda defined environment.yaml. I know there's a big discussion within the Conda community on and Conda Forge just standardizing what the environment.yaml spec is. And I know this has been proposed many times, so I think I kind of want to wait on them and see, see where they go with this. Maybe they'll come out with some extension mechanism, because with Conda-Store, I would have really liked to be able to say, like when you build this environment, it needs to have UID 1000 and group ID of, just having like really tight controls on how things are written, or maybe I'll do like the base image for Docker, being able to specify it there. I thought about extending it, but I think right now I'm just trying to keep it as simple as possible and kind of expected.
Yeah, I mean, I just wanted to open up this discussion because you're interested in reproducibility in general, and reproducibility in general, like, I've thought about this a lot. Like, I don't know where the line is between environment, being defined by just simply installing packages. Okay, well, I still need to do a few more things. Perhaps it's not really a package thing, right? And it may not. It's more of a configuration thing sometimes, right? So, for example, one configuration thing is the environment variables, right? So you can't specify an environment variable in the Conda YAML.
Yeah, so I mean that, and it would, I guess technically something like that could be done, because like Conda has an activate script. So, we could add like, an activate, and this would be just like a bash bit here, it's feasible, but whether that makes sense or not.
I feel like the base, I think it all comes down to, instructions, like line by line instructions, no matter what. Like that's how I feel like how you could solve this problem generally, right? It's almost like structure your environment, describe it in whatever way you want, and then it kind of like compiles into like lines that it gets executed sequentially, right? Gotcha. It's like you want to generate some lines. You want to generate you want to generate conda installs. You want to generate the lines that you would put in a Docker file, that kind of thing. That's gotcha. The only thing that I really, because I've put up the GitHub issue where in my practice what I do is I work multiple environments simultaneously for the same project, and it works absolutely wonderfully. Through I work through wrappers, and it works in like very, very nicely for the data science use cases. And so I don't have like a single YAML to achieve this. It's like, okay, I need a bunch of these environments, and these environments work together, right? So again, same thing, regardless of the structure, it comes down to, okay, just, issue these commands on this computer, right? Right. And with Conda, it solves the problem of, well, just specify some packages and it'll work out the Windows versus Linux stuff, and Mac. It's like you want to do like a Conda build for environments. That's what I've been looking for.
Gotcha. Yeah, that'd be cool. I've also thought about too, here we're kind of sticking to the Conda spec, but I mean, we're talking about environments in general. Like we could just throw in Nix, for instance, and start doing like, our definitions here. And there's really no reason that we should be like stuck to one. This could be, but again, I've thought about these things, and I totally get it, but then I also think like, how is IT supposed to enforce these sorts of controls, and maybe trying to actively limit scope on this too, just to make it.
Yeah, no, I definitely see where you're coming from. Oh, and the other thing that I didn't understand is, well, IT can just say, here's our central package repository. It could be a pip, Conda, any programming language specific repository, and then they keep track of that, and you can only install from that. I thought that was their solution. Like they don't get involved with like how you install it, right? You can decouple that.
Yeah. Yeah, I mean, here my dream is that, you know, we can start to enforce like, oh, the channel has to be,
Yes.
you know,
Yeah.
internal PyData. You know, maybe it's an Artifactory server, and
Yes,
we enforce that no matter what, it has to come from there.
So yeah, I can talk about the multiple environments at the same time. Wow, I mean, it just cleans things up a whole lot. Because again, it's like you want to generate. It's like you have a structure for describing things, regardless of how you know, could be up to you how you do it. But then, you know, the end result is just, it's pretty nice, right? So one thing that you can't do with Conda environments is that you can't really compose them, right? So I've figured out a way you should be able to compose Conda environments, right? You could do that with like the Conda Dev, and you compose environments, and it works wonderfully. You can't really do that with working with Docker files. But you know, it's part of the management.
Yeah.
Hey, Chris, this is George.
Hey, George.
Hi, Don. One of the things that we did, and it was super cheap, probably obnoxious thing, but we made these like YAML files that were just fully pinned. And I know that sometimes that can be grossly disgusting, but I do think that it kind of adds some in the flavor that this is about like reproducibility, that maybe the YAML that it gives you is as close as it can be to being a, you know, a lock file. And that's, we did that Conda vendor just to, everything's fully pinned, even, you know, all the nested dependencies.
Yeah, yeah, absolutely. But kind of my hope here is that you can kind of have both worlds where, like, I don't want to pin things because I want to allow, like, oh, I need a newer number. Let's just let that one, you know, come in when you do another build. But at the same time, you get the benefit that it was built at a point in time, and you get this pinned file. I mean, the exact one that you would need for Conda vendor. So you could Conda vendor to a specific build at a point in time.
Well, I'm just, if the YAML is there and some things are the YAML will be pinned, in the YAML, is it also pinning like the dependencies of things that you asked for? Like say you asked for those 3 packages, like, I don't know, Jupyter Hub, SciPy, and something else. Is it in that YAML, is it still pinning the dependencies for the packages that are not explicitly asked for?
Yeah, I was hoping that this would just pop up and show that. I'm really disappointed that it seems like my Emacs isn't wanting to load this. Maybe I'm gonna have to open it in Word or something. All right, Word it is.
I was gonna boo you, but then you opened LibreOffice.
Yeah, I thought he was actually going to open Word too, and then I was like, oh, he just calls that Word. Okay.
I guess it's to say, yeah, I guess it's technically not Word, but here you can see it's pinned, right? With everything.
I'm foolish. That's what I was. It was just a simple YAML. I'm sorry. I didn't. It is fully pinned, and I've created no useful discussion.
Well, but what I will say though, I'm glad that I got to show this, because here you can see that it's telling the version and the build, but
That's right.
you can change those things. This is not like, yes, this is pinned, but somebody could be malicious or fake it because there's no SHA attached with this. Whereas if you do the lock file, we can see the explicit SHAs next to them as well. So this might be another way that vendor could use as well.
Yeah, for sure. I mean, yeah, we could always just hash it.
Yeah, and you see it has the same information. You have the package name, you have the channel that it came from, you have the version and the build, and then the tarball. So they're kind of like one and the same almost.
That's the MD5. Is that the MD5?
Oh, is this MD5? Okay, so
I
I guess not nearly as secure then.
Yeah, I think so.
Yeah, well, great question. I guess I can also show this dynamic environment that was built. We can see it's actually running on running just fine in Kubernetes, and it was dynamically built. So yeah, I just think this could be a really, really cool use case of not having, I think everybody here is tired of writing Docker files. I hate writing them. I always feel they're redundant, and I've done it too many times, sort of thing.
It'd definitely be really cool to have like just a bunch of like templatized like Kubernetes scripts where you can just snatch in some string on the fly for something that's like more complicated. It'd be really cool. I hope that it takes off. That people are chaining the strings of packages as images, and they're created on the fly. I think it's really cool.
Yeah, thanks. Another feature I didn't show here was you can actually manage the namespaces as well. So you can have a way to create a Chris and a George namespace. You can restrict users that they can only write to certain namespaces, but they also aren't allowed to create new ones. And in this case right now, I have like the ability to create them. And we see that's added. So when I go to create environment, you'll see all the environment namespaces that I have access to create new ones there.